Now let's talk about FDM-specific features in GrabCAD Print Pro. We just covered how FDM, PolyJet, and SAF have costing, labels, thickness checker, 3D array, and grouping in Print Pro. But let's talk about FDM-specific features. Accuracy Center allows you to laser scan your part and correct for warpage on the second print. And FDM Templates let you lock down your settings for FDM so that everyone uses the same settings. As of recording, these features are only available for FDM type printers, but in the future, they should be available for all Stratasys technologies. So let's talk about Accuracy Center. Before, you'd upload a CAD file to GrabCAD Print, you'd print it, and you sort of get what you get, right? If there's a little bit of deviation, if it's warped to a little bit, what would you do? Have to go back to the CAD and try and unwarp it, right? That's not possible. But now, with Accuracy Center and GrabCAD Print Pro, what you can do is scan your part, and Print Pro will automatically correct for that warpage. All right, it'll warp it back into shape, and you print this second version, this corrected version, again, to get a closer, better, more accurate result. Now, we've had some customers get worried at this point, seeing this diagram, worried that we're changing their CAD files away from their original intent. But keep in mind, the whole point is to get back to the original CAD intent, okay, to get back to what you wanted to print in the first place. We're comparing everything against the CAD, correcting against the CAD, and this actually gets you closer to the file you wanted to print. And we have the scan data to prove it. Instead of being an open loop process, it's a more accurate closed loop. It's taking printer feedback into account. So how do things stack up? Well, every part and every material is going to be different, but for this specific 6-inch part that we printed, we assigned about 50 microns to the random printer error, right? It's hard to assign, but this is our best guess. About 250 microns to systematic print error, 75 to post-process cooling, and then maybe 10 microns to the scanner error itself, right? Adding all that up, you get about 385 microns of error in the original before print. Putting all that together after Accuracy Center, we can actually get that down to about 85 microns, which is about the theoretical limit of the machine, right? You can't get rid of the random error, you can't get rid of the scanning error. The other two parts you can cut down by correcting for warpage. Interestingly enough, the scanner error greatly affects the uncertainty in the algorithm, so you'll see that small scanning differences make a big difference in this process. Now, a big assumption here is that these errors have to be repeatable, the systematic and post-process. That means the same machine, you're printing in the same corner of the tray with the same material and the same head, you're post-processing them in the same temperature room, right? These errors have to be repeatable. Think of it like wind on a golf shot. If the wind's always blowing everything 5 degrees to the right, you can aim 5 degrees to the left, but only if the wind is consistently 5 degrees to the right. So you have to keep everything else repeatable for this process to work. All right, so what type of scanners can you use? Mostly the higher end scanners. You're not going to use your iPhone to scan this. We've tried a couple things out, but there's always more scanners being invented. So for the handheld scanner, we have a Creaform. It's very flexible, but the stationary GOM is the most repeatable, right? It's stationary and fixed, so there's fewer human error inputs. The stationary also seems to be the most accurate, right? Again, fewer inputs, and it's best for smaller parts like the one you see here. For the bigger parts, you can use the ARM or the handheld laser scanner, but that's just what we found. So let's talk tolerances. Before this, I used to think in inches, but having dealt with scanners, now I think in microns. The best scanner we have that's stationary GOM, it might be on a best day plus or minus 5 microns, right? That's about the best you can expect, which is really good. Our handheld scanners, the worst you can probably take is about plus or minus 20 microns. Remember that the error here compounds 4 or 5 times to the error in the algorithm. Moving on to the machines, the best published tolerance on a F900 is about 89 microns, plus or minus 89 microns. And a typical drawing callout, where it's not specified the dimension, is about 250 microns. So a general rule of thumb is the scanners are playing in the tens of microns, and your printed parts are playing in the hundreds of microns. That's how I remember it. Now, what sort of warping can accuracy share correct, and what can it not correct? Well, we can correct repeatable and linear warping. That means if you have a shape that kind of looks like this, and it's just bowing upward a little bit, you can correct that, right? It's repeatable and linear, it's small enough. But if you have a shape that looks like this, and it's warping, you can't. Anyone who's done FEA knows that this shape on the right is a buckling problem, right? Nothing happens, nothing happens, nothing happens, and all of a sudden it buckles. And that's nonlinear. So you can't really correct for that. The reason I'm bringing this up is someone actually sent me a part that looks like this and said, hey, can you correct for this warping? And just looking at it and using your engineering sense, you really can't, right? You can put a stiffener in the middle to prevent this grill from warping, but you can't really warp it back into shape. One rule of thumb is that if the warpage divided by the dimension you're measuring is about 1%, that's pretty much in the linear range. But if the warpage over your dimension is about 2% or greater, that's getting into the more plastic, that's a non-linear type of warping, right? Just a simple rule of thumb. Now let's actually go see it in action. It starts by opening up a model. This can be an STL, but also a CAD file, step file, parasolid. I've got a duct here that we usually print in Ultem, okay? It's tend to warp because it's thin and a high temperature material. You check the model for errors as you always do. And now you go down here to the Accuracy Center tab. I'm going to click on the model and import a scan. This scan is an STL from the scanner. Okay, this is the result of the first print. That's why I call it a before. It's before correction. You're going to choose the units of the scan, and there's some options. Typically, you want to keep the base flat and preserve horizontal features. And then you hit compare. This takes a little bit of time. It's comparing millions of triangles, so I'm going to speed this up. And this is what the result looks like. Red is too big compared to our CAD. Blue is too small compared to the CAD. What you want is a shade of white. Up here at the top, you've got a print accuracy score out of 100. Okay, think of it like an English paper. 29 out of 100 is not a great grade for an English paper. And you've got some tolerances on the right-hand side. The tolerance is set per the machine. So a print score of 100 isn't perfect. It's just the best the machine can do at that size. Okay, here's the tolerance slider here. I can make it more or less colorful. Perfectly white is, 100%. That's what you're shooting for. But at this tolerance we've automatically set for this machine and this size part, we've got about 30 out of 100 and the red and the blue you see. I can export this corrected WAM warp adaptive model as an STL for printing on a third-party system like a Metal Printer, Formlabs, or Markforged. Or if I hit print in Stratasys in GrabCAD Print here, I can print it on a Stratasys printer, right? It's already corrected. It's just waiting for me to hit print and go. I've already got the better version on my tray right now. So if I go to the top, and let's say I've printed this version and scanned it again, I can add another iteration and compare. So let me go ahead and add that second iteration, and this will be the scan after the correction. So I call this my after scan. Really, this is my second print. You can call it whatever. I'm going to choose the same settings and compare, and I'll speed it up again. And this is what the corrected version looks like. You can see the second version is a lot better. There's a lot less red and blue, and the print accuracy score is 81 out of 100, which is a pretty good grade for an English paper. You'll never get to 100, but 81 out of 100 is pretty good. Down here in the histogram, you can see the number of triangles that are deviating from the center point is a lot smaller, and it's a bell curve, which is what you want. What it's basically doing is removing the outliers on the side. You can see the old version in the black line here. Okay, and then you can export this as well if you want to take it somewhere else. But this is the second print. You can see it's a lot better than the first print. And that's how you use the Accuracy Center. Now let's move to the second feature that's FDM specific, which is FDM Templates. Let's say you run a 3D printing shop and you have certain rules you want all your operators to follow. What are these rules really? Well, it's a combination of a material plus some sort of infill setting. Or it's a combination of a material plus some sort of slice height setting. Or a printer, a machine, plus some sort of support setting. These are rules. In GrabCAD Print, all those rules and settings are found on the right-hand side. Slice height, infill, support, the machine. So what we're doing with a template is locking down these settings on the right-hand side so that the next person using this file can't change them. It's the same way you might make a PowerPoint template to lock down the color and font size your coworkers might use. So you can think of it as locking down the settings in these dialog boxes. And actually, when you make a manufacturing template, you get to see explicitly the settings you're locking down with a bunch of checkboxes that look like this. As of recording, all these settings must come in a manufacturing template. But in future versions, we hope to have the ability to uncheck certain of these boxes so you can make a template for just slice height or just infill if you wish. But right now, it all comes together. So the workflow is you put a part in the tray and you save out or export as a template a print.mt for manufacturing template. You give that template to your coworker, and when they open it, they see this restricted project warning. And if they try to change the settings, they see this warning saying the settings can't be changed. Let's see what that looks like in the software. So here's an empty F900 tray, and it starts with adding a model. You have to have a model on a tray to have someplace for the settings to live. So I'm just going to throw in a standard inch ruler that I always use. And once it's on the tray, we can actually start applying the settings. So let's say I'm going to go over here to the material, and let's say something like nylon 12 carbon fiber, right? So we're going to make the settings for that. We want the smallest slice height all the time. And for the infill, we always want it to be solid. And let's say for the support settings, we always want it to be smart. So that's what we want to save. F900 carbon fiber, smallest slice height, solid infill, smart support. So now let's go over to the top and File, Export as Manufacturing Template. It'll give you a little dialog, and you can go through here and see what you're saving, right? So if I go to like model properties, for example, you can see what I'm being saved here. Tray properties, same thing, right? So you can see what's being saved. When you're done looking through all of them, you can go and hit export the template, and it'll make a .mt file. Right? I'll just throw it on my desktop here, .mt file, and then I'm gonna make a new project. And if I go to that desktop file and I open up that .printmt file, okay, there it is. You'll notice the inch part is gone from the tray. It's still in the feature tree and hidden, but as long as it's hidden, it won't print. So it's still there and hidden. But you can see it says restricted project. These settings can't be changed. On the right-hand side, it says these settings can't be changed. So the person with the Print Pro license can make the template, but anyone using GrabCAD Print can use a template, right? Anyone in your organization. So it's a really great way to standardize everything across the entire organization. So those are the two FDM specific features of GrabCAD Print Pro. If you have any questions, you can always email me at Stratasys or talk to your local customer support representative. I've been Shivam Ghosh from Stratasys, and thanks for watching.